In this presentation, we examine pseudocode. So pseudocode represents the design of an algorithm. Although there's no particular fixed notation or syntax, it does need to be understandable. We're going to follow the AQA notation so as to be consistent with the exam board. However, you can use any kind of notation that you want as long as what you're doing and writing is actually understandable. So first of all, how do we represent constants and variables? So to do a variable assignment, we have our variable name, so in this case it's a, and then we assign it using an arrow, and then we have a value here which is 10. So the Python equivalent for that would just simply be a equals 10. And then for a constant assignment, so this is a value that doesn't change throughout the running of a program, we write constant before the actual variable assignment, but also we make the variable assignment capitalized as well, so it just allows us to distinguish between a variable and a constant. And again, we use the arrow to do the assignment. So again, this looks like pi equals 3.142 in Python. So input and output now. So this is where we take input from the command line. So what we're doing here is we're taking input from the command line and we're assigning it to variable a. Python equivalent for that is also given here, and the output then, so this is when we're printing something out, we just simply use the output, and the equivalent there for Python is also given. So with arithmetic operators, the plus, multiply, divide and subtract are pretty straightforward. They're the same in pseudocode as they are in pretty much most programming languages. The ones we need to be wary of are integer division and modulus. So integer division here, where we're taking two numbers, dividing one by the other. So in this example, we're dividing 7 by 2, which gives us an integer value of 3. We're not interested in the remainder, we just want the integer value for that. So we use, as I said, we use the div term here. So the equivalent for that in Python is the double backslash. And for the modulus, this is where we want the remainder. In this example here, 7 modulus 2 gives us a remainder of 1. So we use the mod term for that. And the equivalent for that in Python is using the percentage. So just be very careful, this div here is not the same as the divide. So the integer division is different to normal division. Again, relational and Boolean operators are very similar to how they're presented in most programming languages. So I won't go into these in any great depth other than just present them here as they are. So again, using selection, so if we have if-else and else-if statements, we can present those in a pretty clear and straightforward way using if-then, and then we also have some kind of statement, and then we also finish it off with an end-if. So the Python equivalent for that example is also given here. If and else if, so slightly more, so an if statement with more clauses in. So again, we use if, then, and then else, and we finish it off with end if. And again, the Python equivalent is also given, and an if, an else if, and an else clause is given in this final example. And again, the Python equivalent. So iteration are the loops in our program. So the ones we're interested in are while, for, and repeat loops. So with a while loop, we have our while clause, and then we have our statements within the while loop there. If you notice, they are indented here. You don't have to indent code in pseudocode, but it does really help to do that as you would in Python. And also then you wrap it off with an end while here. So the Python equivalent for that is given as well. So for loop, again we have for loop, a for statement with our statements in the for loop also indented, and then we finish off with an end for. So again, the Python equivalent is here. And then repeat until, which doesn't have a Python equivalent, but we present this here because you do need to know this as well. It uses repeat and until but it works in basically a similar way, the same way as a while loop. with arrays and lists, there's quite a lot of operations we need to do. So we're going to go through each of the operations and one by one. So the first one is setting up an array. So again, setting up an array is very straightforward, similar to setting up a variable, except this time we have our square brackets here, much the same way as we actually do it in Python, and then we list our values we want to enter into the array. So in this case we're entering 1, 2, 3, 4 and 5 into our array, and our array then becomes A. So to access an element, to access the first element here, we just simply have the name of the list, the name of the array, and within that then the element number. So in this case, this is accessing the first element, and the value is going to be 1 if we were to print that out. So to update an element, we can actually take our element value and set it, assign it to a value. And for two-dimensional array, so two-dimensional array, remember, is a list of lists. You have to think of it in that way. So it looks like quite a complicated arrangement of square brackets here, but they do make sense and they are intuitive. So in our first row we have 1 and 2. In our second row we have 3 and 4. And then to access a two-dimensional element, much the same way that we access an element in a single-dimensional array, the example for this one, for instance, we're accessing element at 0 and 1, which is going to be row 0, which is the first row here, the second element in that row, so it's actually going to be accessing the value 2 there. And then to update the two-dimensional element, it's much the same as updating the one-dimensional element as well. So subroutines are the term we use for defining both procedures and functions. Remember, procedures and functions are slightly different from each other. Procedures don't have any outputs, they don't return anything, whereas functions do. So straightforward subroutine here, just printing out the word hello. So we have subroutine at the very top, the word subroutine, we have the name of the subroutine, followed by brackets, and then we have the set of operations within the subroutine. Again, it's indented so you can see it's within the subroutine, and then you have end subroutine to finish it with, and then the Python equivalent of that is also given here. And then functions that has both parameters and return values. So in this example here, we're just adding up the numbers up to a certain value. So again, we have a subroutine called add. It has a parameter called num here, just one parameter, and then you have the operations within the subroutine, finishing off with the return here to define it as a function rather than a procedure, and then we end subroutine. So the equivalent there for Python is given as well. When we want to use built-in functions in our pseudocode, so we could just take the actual name of the function from the language that we're interested in, so in this case Python. So to get the length of an array, we just simply use the same function name as we would in Python, so it's going to be exactly equivalent. To get a random integer, the way we can do this is just have it as a random int or integer, however you want to call it. So you can really just name these functions kind of what you want to be honest, because whatever they are, as long as they're clearly named, it should be obvious what that does. So this selects a random integer between 0 and 9, and then again the equivalent Python there is given for you so that you can see. So those are the most often used bits of pseudocode presented to you. There are others, but we won't go into those other ones, but those ones are going to be the most likely ones you're going to be using.